first customer presentation of the day. It is by Spirit Aerosystems in partnership with us here at Oros, and it's called Model-Based Specification Compliance, Transforming Analog Documents into Digital Models. So I'd like to introduce to you Darwin Peterson of Spirit Aerosystems. He is a technical fellow in manufacturing engineering at Spirit and is a member of their core ME team. And joining him will be Tara Mullis, who you know from the last presentation, and I know I introduced her as our senior solutions consultant, but she's also our lead aerospace consultant as well. So Darwin, Tara, stage is yours.
All right. Thank you, Jim. We're going to be talking about model-based specification compliance. That's that other use case that we were talking about that has prompted the development of Cycle Composer. Darwin did all of this before AI was a thing. So we're going to really be talking about the strategy and the manual side behind it, rather than the AI functionality that you just saw. Just a quick little bio if you want to look at it later about our backgrounds. We're going to start off with a broader overview of specification compliance and the pain points and the problems that we see. And we actually have presented on this 2 years now at GPDIS, which is predominantly an aerospace conference. We've seen a lot of consensus, not just from our customers, but also from others in the industry, that this is a pretty accurate diagram of not only what exists today, but the problems with it. And so we talked before in the last presentation about the first two steps, right? Those internal and external specifications, and then those internal proxy policies that enterprises use to comply with them. We didn't really talk about the rest of it, that deploy circle. And so we're going to get to talk about that today. And I want to point out, Darwin actually coined this phrase. Between each of these steps, you have these, what he called a zone of chaos. And that's that highly manual, highly error-prone activity, which per compliance, you're required to audit, right? And not only are you required to audit each of those steps, you're required to audit your audit process, right? You're required to make improvements on, are you auditing sufficiently? And are your audits surfacing the things that need to be done? And that adds a whole nother layer of complexity and pain, I'd say, to the compliance process. So after you have your proxy policies and you've managed to connect them back to your specifications, you now have to actually figure out how you're going to do those proxy policies. You have to budget for them. You have to allocate people to go do them. You have to have timing events and trigger events. And so that's the plan piece, right? You consume your proxy policies into a plan, but again, you have to manually try to align them and try to validate to auditors and to yourself that you've actually consumed all of those policies into all of your plans and you've done it correctly. And then once you have your plan, you have to actually go execute the plan. And you have to validate that all of the execution activities were done in compliance with what was in the plan and in the policies and in the specifications. And then after the execution, you have to, in many cases, have, there's document retention requirements and there's proof of compliance reporting requirements. And every single one of these steps today, I would argue, is pretty much done manually. Whether you're printing things off and sticking them in binders, whether you're trying to do it in Excel, whether it's sitting in some compliance specialist head who sits in the room with the auditor. This is a very time-consuming and error-prone process that's very painful. So the example that Spirit has done, and that Darwin's going to talk about today, is what we call a hybrid model. And in this case, the authoritative documents, your specifications, are still documents, right? They live in a PDF file, and that's not going to change anytime soon. So rather than try to convince them to go rewrite their specifications as models that you could then consume, which would of course be the more ideal way of doing this, you change the things you can control, which are these proxy policies. Like we mentioned in the last presentation, if you author those proxy policies as a model, they're now discrete, and you can attribute them backwards into the document to have that compliance back to the authoritative source. But let's talk the other direction of the deployment. The really special part about authoring your policies, and for those of you who are already in ORS and have been in ORS, you likely already know this, you can consume those policies into a larger model, an orchestration model, which is then the plan. You're not copying and pasting, you're not creating duplicates, you're actually inheriting those proxy policies, and that proxy policy can be inherited in 2 places or 50 places. And when a change is made, that change populates to all the places that it's being consumed. And that orchestration model, with all of the models that it contains, when you go to execute it, you're not, the execution is not a separate activity, you're simply instantiating the model, right? You're taking a model from a timeless, generic, standard, repeatable process, and you're turning it into a specific instance. Me, Tara, today is going to conduct a bend test, and I'm doing it in Phoenix, and I'm gonna do it with this piece of metal, and it's gonna be for this airplane, right? So all of that metadata that you get from instancing the model, and then all of the variables, the evaluated numbers from your parameters during that instantiation, during that execution, all of that becomes part of what we call the model data footprint and transaction retention. All of that data is now available for proof of compliance reporting and for internal reporting. For continuous improvements. And so now, instead of doing all of these different manual audits and all these different manual root cause analysis activities and process improvement activities, if you want to answer the question, are we compliant, or how compliant are you, you're really just running a report on your current status. And it's just a continuous reporting activity with no manual stuff in it other than, hey, I want to go look at the numbers and I want to draw some conclusions.
Okay, so let me give a little background here before I dive into this one. When Tara and I put this together, and as she mentioned, we've given this presentation or version of it the last 2 years, it's focused, and we're using language about specification compliance, but the work that we've done at Spirit is far more than just specifications. So think of anything that's important that you do in your business, regardless of the job role or whatever in the business or any business. You can apply these principles everywhere. Business behavior people always laugh and say, well, here's your business writings, but here's what people really do, right? You all know that the informal tends to take over the published formal all the time. So one of the things that's really important is, what about all the knowledge that's not in a document? So in a few minutes we'll talk about that, and we'll show some examples about that. Sometimes it's even combinations. So as Spirit Aerosystems, when I hired in 37 years ago, it was Boeing. And probably before the year's out, we're going to be Boeing again, which many of you may already know that. So it's been an interesting journey. And the differences between being the OEM and then the Tier 1 example and having to deal with the issue of same basic process, but many different specifications by different OEMs. And the way they structure the content is very, very different. So let's talk about torque. In the example that the basic model that Tara showed a moment ago, we had a real challenge with this. So the plan would be our manufacturing work instructions at a master data level. Execution is the production order. For things like torque, typically we would just tell them to perform the torque per specification, okay? So that's obviously problematic because what really happens, right? So we're back to the informal. Oh, Joe told me that's 30 inch-pounds. Whoa, what? So if we come back and audit, that's a problem, okay? So you say, well, go look it up. Well, depending on the specification, there are many tables in the specification. There's no nice way to correlate fastener combinations to the table in the specification. So even if I tell them to do it per the specification, that's problematic, okay? They can go search, but now you're asking them to get away from the work, and in our business, depending on where they're at, the computer may be quite a ways away. They crawl out of a fuselage, go over and find a PC, and look something up. So just telling it like it is, that's not happening, right? People aren't doing that. It takes too long. So we knew we could do better than that. A lot of people say, well, just give them the values. Certainly, you can do that. But where are you going to do that? You can put it in the work instructions. That's text. How easy is that to go find or fix? When a specification changes, that updates. Trying to find it and maintain it, extremely costly. So that was not typically done. Some people say, well, great, just make everything in our business, they would call it designated. Just put it in the model, right? Put it on the face of the drawing. That's problematic too. And again, they got to go looking for that. If you give them graphics, and there's the big argument about graphics, well, you just give it all to them graphically. Typically, they're in a hurry. They don't want to look at that either, unless it's brand new to them. Right? So get me to a functional instruction, something that quickly triggers my mind to what is the process and what are the unique process variables involved. So in the case of torque, what's my unit of measure? What's my min and max values? So what we did, and to use this language, I'll try to use this pointer, but maybe that's not going to work too well. So this is just representing many specifications. We worked across, like I say, multiple OEMs, about 17 or so specifications with many tables within them, different structures. So even in the same specification from table to table, the input parameters to do that are different. Okay? I think we're up to about 17 different structures of inputs to get the same set of outputs, depending on the spec in the table. So we built, we'll call them in this case, proxy models. We used AROS and modeled not just tables, but logical constructs about the master data as well. So we used a web application that we built. The MEs used that and access the AROS content. And what we produce for them at this phase is we produce the master data that they need to input in the SAP routing as a master data, okay? So it's not the outputs, it's the inputs, and that's stored as master data. When a production order is released, our MES system uses that data and triggers a call back to the AROS content and returns back in this classification for variables, only in this case in the production order, and populates that. So if I have a specification change, I go make the change here, job done. How many times is it going to get used and when? I don't know, don't care. I can go back and look, right? I know I've taken care of it. So this is just one application of things that we've been doing. This has been in place for several years. It happens thousands of times a day without a hitch. Works great. One of the things that I'd been around this space for a long time, like I say, I've been here 37 years, and about 35 of that I've been involved in some kind of knowledge acquisition and knowledge modeling in the context of process automation. And in doing that, when I proposed that we take this approach, there was a lot of naysayers, I will say. The folks just laughed and said, never going to happen. Well, we made it happen, and we did it in just a few months. They were dumbfounded. And one of the things I told my colleagues, I said, so here's what's going to happen. The minute we start producing this content in here, we're going to get a lot of conversation. It might look like it's negative or angry. I'm going to say, anticipate it, it's a good thing. What you're doing is you're creating conversation that should have happened a long time ago, right? And that's exactly what happened, right? We had manufacturing typically were the first to call and complain, say, hey, we don't think this is right. Then the conversation starts. We might be talking to materials and process engineers. We might be talking to the design engineers, whatever the case may be. We initiated conversations with Boeing material and process engineers saying, we think you need to add something to this specification. Here's a reality that we have on engineering drawings that's going to affect this, we think. You need to go take a look at that. Those are all good things. So when you begin to connect the content much more explicitly, and you're using it this way, it really invites the kind of communication that you really need across the life cycle, wherever that happens to be. Okay?
So I know we talked about this in quite a bit of depth in the last presentation, so we're not going to spend too much time on it other than to say we're coming back to this model of the import, then the modeling, and then deploying, and we're going to step through each of those things in a little bit more detail than we did before, and then we're going to talk about it in context of the experience Spirit had doing this exercise. So for modularization, this is really about figuring out distilling things down to what can operate independently, right? If it can't operate independently without some contextual information around it, then you might not have it scoped large enough, right? But if you have 3 or 4 different things happening all in one knowledge packet, it might be scoped too big, right? So this trying to modularize at the right level is more of an art than a science. Now, luckily, in the specification world, there's 100 years of iteration on trying to get things in the right pieces, and that's usually expressed in document structure, right? So your index and your section 1, section 1.1, 1.1.1.1.A, right? Those tend to be those independent pieces when you go down to the smallest portion of that document structure. And so you can get a lot of gimmies for free. You can get maybe, I don't know, what do you think, like 80% there on the document structure alone?
Probably. Again, it depends on how well the document has been maintained and created. Okay, I'll give you a bad example. I was trying to just document from a specification, a notoriously difficult one in the aerospace business, about one tiny aspect, okay? And to produce a simple little flow chart for people doing hand form. Right? It was after aluminum heat treat. So when is it still in the W condition? You would think that would be a pretty straightforward thing to do. Honest truth, I spent 32 hours. Okay? I'm not a dummy, okay? Might not be the smartest guy, but I was like, this is ridiculous. Page to page, footnotes, little notes in this table, go back to here. I documented it really well because I knew what I was going to do next. I was going to send it to the materials and process engineer who's the expert on it. I sent it to him and I said, okay, take a look. Is this correct or not? He answered me back in an hour. Oh, no, this problem. I'm laughing to myself and I said, go back and look at it again and look at A, B, C, right, that I had documented. He answered me back, he goes, dang, you're right. So if the two of us had that much trouble on that everyday item that literally thousands of times a day in one factory people need to know, you think that's a problem in the documentation side? You bet it is. So answer to the question, it depends. It depends on the specification. It can be really messy. If they're really old, okay? So people, it's kind of the proverbial Band-Aid, the tire that's so many patches you can't see the original rubber. So.
Yep, no, for sure. So once we get past the modularization, right, we've deconstructed it, and now, and again, as actually Carl was mentioning in our last presentation, you want to try to do that for reuse. A lot of times it's going to be on document structure, but we actually have an example from the Digital Standards Alliance pilot where it was a perfect example of this, where the way that they had bucketed it was actually, you couldn't reuse it that way. And we'll show that example here in a little bit. But then you got to move on to classify, right? how do you know which independent piece to use when? And you can only really answer that question if you've classified it. So this is an example from the Digital Standards Alliance pilot. And you can see here just some examples of, we can pull out, because there's this, specimen can be language in there. It's been classified as a requirement. Because it applies to all of the bend tests in this document, the test method that this little piece applies to is every single test, right? And it's specifically around creating the sample, right? So you can start populating these classifications that are really around the who, what, when, where, why of this information.
So just to add a couple of thoughts there, classification is really the foundation of learning. When you come into something new, if you can't classify it, you don't understand it. So the first step is really, how are things alike? We're going to move into next, how are they different? But fundamentally, that's the understanding phase. So you're discovering what's there. It's how big is the domain? Maybe you don't know, especially if you're really new to it. It's top down and it's bottom up. Jeff addressed that some as well. It is part art, it is part science. There's definitely skill, but it is skills that can be learned. And it's really a way of not just modularization, but being able to prepare, and this will be a little more obvious as we talk through the next steps, but this is what helps you to be able to understand how they combine or sequence, depending on what they are. So classifying and the first effort at modularizing really go together.
Yeah. I think one of the things, I really geek out over the cognition flower, because I get really excited about neuroscience stuff. And I think a lot of times people kind of dismiss the memory piece, right? It's just storage. We're just persisting the data to be retrieved later. And I think actually that's the least interesting part about that aspect of cognition. The schemas are the most interesting part, right? How do we classify that stored data so that it can be retrieved only when appropriate? And I think that's why, I know it sounds like really mundane, but those of you that are already in the tool, when you're going into your community of practices and you're configuring your extended element, metadata ontology, like to me, that's like the coolest part because you're starting to structure that memory schema that's going to allow everything else to happen. So the next thing is to parameterize, and I think steps 1 and step 2, modularize and classify, that's where a lot of people have gotten so far. Whether they're using Excel, whether they're using some other kind of tool, they're modularizing, maybe not perfectly, they're classifying to some extent, but they really, for the most part, are not parameterizing yet. And this fundamental idea around, you have a paragraph of text, and in that paragraph of text, you can define the things that are variables, whether they are an input variable or an output variable to the requirement or the piece of knowledge that's being modeled. And so going through and discreetly teasing that out and saying, hey, this chunk of text is a variable, and here's the definition of that variable, here's the kind, right? Is it a temperature? Is it a choice list? Is it a length? Is it a radius, right? Like, what is it? And then you have those in a one-to-n list, and you start seeing how those are getting reused across multiple different requirements. Then you additionally start teasing out, like I have radius twice, and does that matter? Is there an outside radius and an inside radius? Yep, I got to split this parameter into 2 parameters. There's a lot of nuance to this, and I would argue you can never do it top down. You're never going to get it right the first pass out of the gate. You're always going to be iterating on them as you work your way through all of the requirements.
Even if that is simply just the reality of the fact that you're always learning, at least hopefully you are, right? So as you learn, the context can change.
Right.
The domain gets bigger.
And I think the important thing to remember is that this shouldn't be discouraging, right? It should actually be exciting that, at least the way we're handling parameters, the way we're striving to continue to improve on the way the software handles them, is that it supports that activity of iteration, to build upon what you have done before, not to start over when you meet something where it's not quite working right. And so how do we continually evolve our parameters rather than throwing them away and starting from scratch?
May I have one other quick thought there. This also, depending on what you're integrating with, may be very much an enterprise level data architecture conversation. So when you're talking about data going in and out of databases and relating to your knowledge layer like we're talking about here, that has to all be taken into consideration. You're not in isolation, hopefully.
And like your point earlier, it fosters those conversations that really should have happened 10, 20, 30 years ago.
Right.
But this activity of parameterizing forces all of these different siloed groups to be very discrete and to become interoperable with each other.
And anybody in the data space has all had experiences like this one, where you get this little software that got created, it's now become legacy, you're using it, and who named that stuff, right? Some analyst that didn't have any connection to the factory, they just built a database and named that thing, and all of a sudden you're stuck with that thing for the next decades, right? So you have issues with, mapping parameters, A equals B equals C, and et cetera.
So some of you may have seen this before, but a byproduct of parameterizing is parameter threading, which Jeff mentioned earlier. What you're looking at here is actually a report. It's not something that was created manually. It's not something anyone had to spend any time doing. The information is already there to create this report just through the activity of creating parameters and starting to consume them into component models. You get all of this information and intelligence for free from that activity where you're reusing parameters across multiple models. So the next step is to build those component models. We call them component models because as soon as you really get into this complex space where you have lots of different requirements interacting with each other, you quickly realize that very seldom does a requirement stand on its own. So very seldom will a model stand on its own. You have models which are built upon other models, which are built upon other models, which consume additional models, and it gets very complex very fast. And so it's really good to think about these models as kind of Lego building blocks rather than unique entities that get treated independently. And so like with Legos, you want to start with the foundation, you want to start with the smallest bits, and then start assembling those bits into bigger pieces as you go along.
So a thought with that. When Tara and I did this related presentation last year, we did this in reverse order. And we weren't focused so much on the conversion process. There were a lot of questions about it, which is why we adjusted this and took this approach. But I would say it's kind of both. You begin with the end in mind, and that'll be a little more obvious as we talk through some examples that I've built. You have to start left to right in terms of building, but you're also planning from the other direction. Okay, and that'll become a little more obvious, but you're creating for use cases, and maybe another way to say it. Right? You're understanding the consumption of the content, and that's part of this understanding. So by the time you get to this point of trying to make a model, before you go any further, it ought to become a lot more obvious by this point where you're at. Okay, are the models making sense? And by the time you do the next step, it'll be even more obvious.
Yep. And I'm going to skip this video because you guys got to see it earlier today. And so now we get into grouping, which is where it starts to get, I think, kind of exciting. So you're really having to think about all these component models that have been built, and you might have some simple examples of higher level models, right, where it's 2 or 3 components, stitched together through a higher level model. But you have to ask your question, does this model work on its own, or does it only work when it's evaluated together in a group of others? And that question sounds simple, but can be actually really deceptively complicated.
So let me interject a thought about that as well. I think one of the real values at this level in AROS, these are sets. So they're just groupings of knowledge packets or the component models We're going to look at examples. This is out of aluminum heat treat, primarily a Boeing specification here, but also a Spirit one are combined, and how this is done. So this is a PowerPoint documentation that I made to illustrate the content. So the blue boxes, you can see the KPAC or knowledge packet identity, the input and the output, what happens. The red lines represent what the rules engine is doing in terms of processing outputs of one that may be inputs for another. Some things may stand independently on their own, but in terms of a logical sequence of processing, they happen at the same time. So you include those, okay? You can see there's quite a few in here. One of the beauties of this, from my perspective, at the rules engine level, is this functions just like an independent KPAC in terms of processing. So it's just another model, in this case, combined. There's a little video just illustrating the same point like we've seen earlier, that it is actually a model and can be executed independently, or in the case of the whole set, can be executed in terms of walking through it manually here as well. I want to, when this finishes, I'm going to point out something else here.
Can we go back?
Yeah, go back to the prior one. Thank you. Okay, you notice here that I have a series, okay, just to save space. And you also notice I have a couple of these where I mentioned the specification and the table. So you have one specification in this one set, but multiple tables. And you also have content that is about the manufacturing facility, okay? So this is another context issue. This happens to be our facility in Wichita. I also do aluminum heat treat other places. All I have to do to reuse this context without recreating anything new is make a new set that replaces these with the relevant content at the other site, right? Quick way to reuse the same content. It's not a whole new creation, and can represent. Some of these things may or may not be as well documented in a business writing. They're not in a specification, right? They're on the manufacturing side. That is just documentation about what resources you have, what parameters that you operate within, etc. Okay.
And they might be dynamic, right? They might change. Your
Absolutely.
number of mechanics who are certified for heat treat might go from 2 to 22 year to year, and that might then change how many positions they can staff with them, which then totally changes a bunch of other requirements. All right, so next we talk about orchestration. Orchestration is where we now take these groups, and Darwin already touched on a little bit with those red arrows, but those groups, and say, how do they relate to each other, right? Do they operate independently? Are they conditional upon each other? Are they a predecessor or a successor to each other? And that orchestration is really where the magic starts to happen. That's where these things actually become usable in a context, in an instantiation. And we're actually going to show a couple different examples of orchestration because there's different styles of orchestration available in the software.
Okay, so this is back to the heat treat example. This represents, so each of these little boxes you see a set number. So these are models, but typically have more than one KPAC in them. And in this case, from this logical content that's put together is solution heat treat, precipitation heat treat, and temper verification. So hardness values, conductivity values to be provided. That looks a little scary. If you had to go do that as a manufacturing engineer and create those three operations, you have to know a lot of stuff. One, you got to know what specifications to use. You got to walk your way through a really complex spec that is not very obvious. Here's another example. The materials and process engineer, who's the expert in this for many years, before I started to create all this content, I asked him about a logical sequence of creating the content. He gave it to me, bam, right off the top of his head. I spent weeks trying to do what he suggested, and one day just kind of sat and chuckling to myself at my desk saying, no, not going to work. Rearranged it, worked through it very rapidly. And I went back and showed him. He's like, So if you're the person trying to sit there and work your way through multiple documents, multiple tables, collect the information, and not make a mistake, and then get it in the master data, that's a pretty daunting task. Takes a very, very long time. We're going to look at this in a moment. So one of these sets that we looked at a minute ago, all that content is just that one little box right there represented. So the approach that we took is similar to what we showed you on the torque. There's a web application for the ME. In this case, there's not something happening at production. We could do that approach. We decided not to in this case, say for conductivity values, but we could take the same approach. Because all the content is modeled here. But the idea is for the ME to use the web application and this to produce all of the content for them out of these models that they need to put in the master data. What work center to apply, what's the standard text, what are the process parameters, etc., to input. Okay.
So one additional style, some of you may or may not have experience with this in the tool, is using a process model. It's currently called a method. We're in the process of converting over some of the naming conventions of our features, so it's going to be called a process model. And this is actually an example from a model-based quality use case in NSRP, so in shipbuilding. I know it's really big because this is a really long, kind of complicated manufacturing process. But in this example, the requirements from the manufacturing engineer are all component models that they can edit at any time. So when the manufacturing technician comes and engages with this orchestration model, it might give them different instructions from what they got yesterday, right? Because that manufacturing engineer may have gone in there and made revisions because there was a revision to the spec or to a best practice or a manufacturing requirement. But they're always interacting with whatever is current and live. And the value in doing it from this method, this is a much more hands-on method with the shop floor, is in situations where there's a high number of unknown variables until you get to the shop floor, right? So where when the mechanic has a high level of discretion, or there's just a lot of variables that are unknown until you're actually building the thing, which in shipbuilding and some spaces in aerospace are very much the case. It's really, there's no way the planner is going to be able to plan for all contingencies. So in this particular example, the mechanic has an option of 6 or 7 different stock plates from their supply shop, and they can pick any of them to go and make a piece of decking from. And based on which one they pick, they're going to have completely different requirements, completely different manufacturing process steps that they have to do, completely different quality verifications they have to do. So by the planner putting in those requirements and then the mechanic selecting those variables as they go in that instance, they're then only conditionally given the work instructions for their next step that's applicable to what they just did. And that becomes a very powerful model when you get into these complex manufacturing processes.
How much a more dynamic build?
A much more dynamic build. And a way for planners and designers to have a huge amount of visibility on what people are doing, right? They can have visibility on, hey, 80% of the time they're choosing stock plate 3. Why is that, right? Maybe supply chain doesn't have to stock plate 1 through 2 anymore, right? Maybe we can get rid of that and get some efficiency in our supply chain. Maybe there's a design reason for that we could get an optimization out of it. You don't get any of that execution data when you're just saying, hey, I did what I was supposed to do in an execution system.
Right. And from a perspective of how do you deal with those? So at a specification level, you get lots of options often, right? That's not even addressing the issue of substitutions or supersessions, which gets really complicated, okay? So from a manufacturing side, I say we don't like options. That's not nice, right? Creates too many unnecessary complexities to respond to. But there are things that you can't do anything about, right? Particularly when you start running into something like, say, nonconformances, right? The unexpected happens. How quickly can you respond to those? So lots of opportunities in that space, particularly for dynamic. Or even if you are trying to address things like options, choices that are available, either on a design side or at a manufacturing process, master data situation, all of those can use the same approach and address it, and you could be capturing what those decisions are and why, right? Contextual decisions. So in this case, we're using this option, and here's why. Document it, use it.
And I think really when you see lots of options, whether again it's in the design engineering space or in the manufacturing space, that's evolved naturally because you get in situations where would you rather give them only one option and stop production or stop the design, which is costly? Or would you rather give them multiple options that when they hit a certain scenario, they can go a different path? So when you get these situations where there's lots of options, it's usually because there's a history of, ooh, if we'd only given them the one option, work would have stopped, right? It would have delayed the delivery of a design. It would have delayed the delivery of a product. And some of those you're going to be able to model discretely, and now you can have these discrete things where it automatically filters them to the right option. But in other cases, you may not be able to, and this allows for that complexity to be supported and to be managed in an efficient and effective way, not trying to pretend that it's not necessary. I think I've through my whole career at least, the message I get from leadership constantly is, oh, we just need to remove the options. We just need to get rid of the complexity. It's like, no, the complexity is there for a reason. We need it. We just need a way of handling it better. All right, now we're into the fun stuff, rationalize. So I'm going to share some examples from the Digital Standards Alliance pilot that we've done, and Darwin's going to share a couple of examples that he experienced in the process of doing torque and heat treat. But this is really where you start to tease out problems that have been there all along, but you really don't see them until you start modeling things discretely. When they're in free-form text, and that's interpretable, it's really hard to see these things. And as soon as you drop it into a model, it becomes really obvious. So we found multiple examples of duplication in this specification that we did. It was a bending test with ASTM. They had the same requirement called out 5 times. 5 times they called out the same requirement. And that becomes really, and it was phrased completely differently in completely different parts of the document. And it became really obvious when you're building the model and you're like, hey, it's exactly the same model I'm building over and over again, right? And the system can automatically pick that up and go, hey, you just did exactly the same thing over and over again. You have issues with ambiguity, right? Where when you're trying to parameterize and apply operators to those parameters, you go, oh, you know what, they actually didn't define this ratio. They said it should be a ratio, but they didn't say by how much, right? So it very quickly becomes obvious where your points of ambiguity are that need to be closed. And gaps is kind of similar to ambiguity, but gaps where, they've just, I guess ambiguity is more something could be interpreted multiple ways versus gap is truly, there's just a piece of information missing.
Something missing, yeah.
Right. And then we had a great example of a conflict where in this particular pilot, it was a 1-paragraph portion of an SAE spec that invoked the ASTM spec. So it said, perform a free bend test per this ASTM spec and comply with everything that's in that ASTM spec. But it put in a couple of requirements about specimen width and ratio and a couple other things. I think it was 4 or 5 different requirements. And when you went to the ASTM spec, their specimen width requirement was in direct conflict with the ASTM requirement. So you actually can never comply with both specs. You can either pass SAE or you can pass ASTM, and you can never pass both. And that's something that the system automatically found. Even when I was modeling it, I didn't notice it because I was modeling completely different things. But as soon as you executed and instantiated those models, you went, oh, I can't pass both requirements, right? It's immediately obvious. And it's undebatable, right? Like you can go back to the authors and they're not going to argue about it. They can see it for themselves and go, yeah, we do have a problem and we have to figure it out.
Those are the kinds of things that tend to be hidden when you're operating on lots of assumptions about what a human is doing.
Yep.
Did they find it? Did they interpret it? Did they incorporate as intended? And people just either don't see these, or it's too much trouble to try to report them and they just decide and go on. All of those happen.
Yep. And then the last one is discreteness. So when we were talking about grouping earlier, this was a really interesting example for me out of the SAE spec. They had a paragraph, which, by document structure, that's one KPAC. But the first portion of the paragraph had to do with creating the sample. The middle of the paragraph had to do with the examination of that sample after the bend test, so a pass-fail requirement. And the end of the paragraph had to do with how to actually perform the test, at what room temperature to do the test. So when you look at groupings, those are actually 3 completely different groups, and they happen in 3 completely different portions of the orchestration. And so it's actually impossible to have all 3 of those things in the same KPAC. Because you have to conditionally provision them at different points. And based on how creating the sample went and how testing went, that evaluation requirement may actually not even be relevant at all, right? So you'll always have to kind of get back to these backwards arrows, you oftentimes, as you move through these steps, you find that things you've done earlier need to be adjusted because now suddenly you can't do the orchestration the way you need to. So you got to go back and adjust your modularization, go back and adjust your classifications, et cetera, et cetera.
So we had one this past year relative to a parameter name, and as I continued to build content and work with it in some other contexts, I realized I was spending an inordinate amount of time relative to a couple of them that were related. Decided that the problem was the name. I really needed to change it, and when I was gone, whoever followed me was really going to struggle with it if I didn't modify it. So that happens. Just expect that it's going to happen. Those kind of things do. Again, you gain more knowledge, you have more contextual use, and you decide that you need to refine something, right, to make it more clear.
And I think where we're really seeing this resonate with folks is today, if you find an issue in a specification, you could be looking at a 2-year process to fix it, right? They have to go through a really robust process of the authors going and validating that the change needs to be made, figuring out what the change actually needs to be, and then everyone who has ownership over that entire document has to sign off before they can revise it. And so it's just really leaden with red tape because you affect one sentence on page 23, all 53 pages have to be approved for revision. That's costly and expensive, so they tend to like to collect changes, right? And also they don't want to be rolling out a new revision every 2 weeks or whatever. So, it creates a very non-agile environment. And so a big advantage to doing specifications this way is that now you can very strategically and in a very targeted way just go in and pick out the one little change that needs to happen, and only the people affected by that change, only the owners of that little tiny piece of information need to sign off on it. You can life cycle that requirement on its own and not as part of the overarching document. And so you can now much more rapidly do the improvements and the changes you need to get everything working the way it needs to.
Agreed.
So the last piece of this is instantiate reuse, right? And this is where we've talked about a lot of benefits around the authoring and the maintaining side, but this is where you see the benefits to the people actually using the specifications. We're going to show an example from Heat Treat for those planners.
So I mentioned a few minutes ago about the web application, and that's what this is. This is just a quick video to walk through an example. We created what we call a debug mode that reports back the sets that it traverses. So if you remember the big map example, PowerPoint, that's what this is showing you is where it's going to produce the content. It only asks for what it needs to ask as it progresses through the logic. And it's going to go through, I think, 15 different sets of knowledge to produce these 3 sets of data. See, that's quite an effort to produce conductivity and hardness values. Conversions, it depends on what tool you're using and all the other conditions about the material or the part. So did that in less than a minute. Okay, if you're expecting a person to go do that, look through, in this case would be a combination of at least 3 specifications, more than a dozen tables scattered through large specifications, and at least 1 other business writing to come up with that. I think this is a whole lot better way. It's a whole lot easier to show, 1, sequential relationships, what logically should happen before another, what logically should happen together, and be able to explain them, right, explicitly.
And with that, are there any questions?
So, Darwin, I made the claim in the initial presentation that model-based cognition addresses the issue of complexity. And I also made the claim that this demonstration, yours specifically, and the work you did, addresses that. So my question to you is, okay, documents are tough. You just said why. You know, person traversing these documents will produce all kinds of human error, including just avoidance of the work entirely. You've been doing this a long time. Why didn't you automate the process programmatically? And why does model-based cognition, or the Oros approach to it, why did it enable you to do something that you couldn't do with just the automation tools that you had available to you?
Absolutely. So I'm going to back up a bit. From my perspective, and you don't have to agree with me, okay, it's one of the beauties of getting older, you care less about what people think. People matter most. Okay? I approach this more philosophically than technically. My simple model and perspective that I have been trying to communicate to leadership for a very long time is this is a transition opportunity in job roles. So if I take the time, okay, that I should have gained by doing just this as an example, and there are a lot more, but if I just use that example, I say, I take these technical people that cost me a lot from a leadership standpoint to hire these people. If I take the time that I save from turning the crank in their regular business, and I now transition them more to call them knowledge workers, knowledge engineers, I'm going to deepen and broaden my product and process knowledge. And I'm going to incorporate it, and I'm going to reuse it. So it's a win-win no matter how you look at it from my perspective. It's easier to explain, it's easier to incorporate, it's easier to maintain, right? I can show traceability like Tara discussed a moment ago, from a life cycle of even more granular content, the way it's managed. I can show its incorporation and its use. Right? It's easier to go find if I have an issue to go address it. And the automation is a way to, 1, enforce and reuse, but it also buys me more labor that is extremely more valuable. I can use those resources to learn more, right? I hope that answered your question.
You tried, if my understanding is, you tried to automate before, but the simple permutation of the combination of all these variables was untenable to manage in a top-down way.
So let me a little more history. So when I hired into Boeing in 1988, Wichita, Kansas, I finished a 2-year intern program. At the end of that time, the Research and Technology Group had created a process planning application. We called them expert systems then, right? And they were looking to get it into production. And it did sheet metal and small machine parts, things like that. So it created the entire manufacturing plan, tool orders, etc. but we had no access to CAD data or things in those days. So this was about 1990, okay? And I went to they were looking for a system manager to get it into production. So I went to my new boss and I said, Doug, I want that job. And he's like, you haven't been here long enough. And I said, Doug, I will do a better job than any of your leads can do on this. He says, oh, really? I'm intrigued. Keep going. I said, here's why, and I can say this with confidence. Because they think they know, and I know that I don't know, and I will go find out. So that was the career door opener, and Doug I will always appreciate because Doug said, you got it. And he got out of the way, and for the next 35 years, I've mostly done my own thing, and they've let me chart a course, and it has always been in this direction, and I've literally spent my whole career trying to create this opportunity that's here. I didn't have any modeling tools back in those days. So that application that we called Kappa at that time, we used it for 20 years in production. It was one of the largest of anything like it that we were aware of in the industry. And there were others in aerospace, and we did some comparative tests. But in the process of becoming Spirit Aero Systems and working 60-hour weeks to stand up new systems, it went by the wayside. We lost all that. So one of the things I'm anxious to go do is recreate that, only with a whole lot better tools. We have access to CAD data now. We got a graph database we can use, and I got modeling tools. So, yeah, I'm going to say there's nothing to lose here. Pick whatever your domain is, whatever your value space is, and get started. I don't see any competitors, honestly. I don't see anybody offering anything like this in terms of a generic modeling tool that you can use for humans and for software. And again, my perspective is why the automation? Because it gains me much more efficient use of my technical resources while it reduces my costs and improves my quality.
So I have a question. Maybe it's a clarifying question.
Sure.
Because I think is it the build and the iterate is yet not necessarily available? Because my question is about the grouping of the CAPEX. Is that something that's available, or is it in this
Yeah,
we're
so
developing it kind of stage?
every piece of functionality that you saw today is currently available in the tool. Now, is it available with an AI assist is maybe the better
That's my next
question.
question. Yeah, because I'm wondering the grouping of the CAPEX within a COP automatically based on something, and that be
Yeah, so we have
Generated.
collection models today, right? There's
Yeah.
a couple different flavors of collection models. We do sets, which is what Darwin predominantly used. You can do sub-assessment models within an orchestration, which does the same functionality. And there's also business rules that can be written, which is also a form of a model. All three of them do dynamic collection, right? So all three of them, you can set up that model of what the collection should be. And then as the data that is the resource, right, of things to be collected changes, dynamically the results of that collection are going to change in real time. So that functionality does exist today. Now, do we have the AI functionality to go look at the specification or group of specifications, 17 different specifications, and make suggestions around what groups you might want to consider? That's still ahead in our development horizon chart, right? That's, I think, the one after the one we're currently on
okay.
right now.
That's what was my question. Thank you.
You bet.
Yeah, first of all, that is an incredible model that you've put together, recognizing the problem from multiple problems, recognizing that they were really all the same thing in the process, and then going through and executing that. That's unbelievable. But I have one question. You talked about how the change affects the operator and that it's seamless. They get a new build sheet and it's got the new stuff on it, and that's great. But you've webbed in, multiple regular, documents, specification documents, and things like that. What happens if you get a new one, or if something changes majorly in those? I don't want the details, but just kind of discuss
Sure.
how you, update.
Right. So as a tier one, of course, we're on a keep up to date process with, things like specifications from the OEMs. So in the case of Boeing, for example, we get a weekly Friday list that comes to us with a group of first reviewers. I'm one of those people. I look for things that, does it affect me or not? Typically, a change in a specification, you got like 90 days to incorporate it, things like that. So there's obvious needed working time for people to do so. From my point of view, in this case, it's a whole lot easier, right? If it's just a value change, it's really quick. Let's suppose it's something major, right? Structural. Again, I usually have way more time than necessary to incorporate it in this approach. If it were something more legacy-wise, it might be much more difficult. I mean, I'm busy trying to go query master data, look for things, search through other documents, etc. No, we don't. So I don't have a sandbox ROS instance. It would be nice to have one.
We can get you one, Darwin.
I don't have one. It would be nice to have one. Where I could migrate and test just like I would migrate other softwares that are in production together to go from dev to Q to prod, which is a typical model. Yes.
Yeah.
Correct. Yeah.
And,
So that's how we do it, right? We test the incremental pieces, and based on what we're doing and our knowledge of it, we haven't had issues. But
And I think, at least in my experience, or my work experience, there's changes that don't universally apply, right? There might be a new change comes out that says, hey, this change only applies to airplanes manufactured in Germany, right? And so now you have this new conditionality that's in place that never existed before, right? And that process of tweaking your grouping and your orchestration model and your metadata, your extended element, infrastructure. Again, Oros is really designed for that to be an agile process, that you don't have to pull everything apart and start from scratch. You just make one surgical little tweaks where you need to add that extra layer of complexity in. And so, yeah, you don't need the 90 days that people need when they're trying to do it manually through text, which is what most people are doing today. Yeah, I think when you start seeing every participant in a value stream from the beginning to the end interested in the same solution, it's a really good indicator that is where things are headed. And that, like Jeff said, that is what we're seeing. From the standard owners and authors to the OEM consumers, to then the tier one consumers, to then the auditors, the regulators at the end, all four of those groups are intensely interested in this approach. So it's I think, a really exciting time, considering that it's been 100 years since standards and specifications have changed. You can go back and see the rules for baseball from 100 years ago, and it looks exactly like the rules of baseball today in the same format. So it's, I think, really cool.
I can validate that's really true. Again, we're still a tier one. We're about to be back to the OEM again. But when some of them saw these things that we'd done, some were really excited and some were kind of irritated. And my answer with a smile was, I would love for you to take this over, right? You're the OEM. You own it. Deliver me a model that I can subscribe to as a service, and I won't touch it. Please. Right? So this is what Jeff's saying, and there's a lot of excitement. People are catching on, the lights coming on about this topic, realizing, how much cost is in a supply chain in a large manufacturing business with just this topic. If you broaden it to everything that is in terms of how they do business today, your internal content, it's pretty staggering. I mean, I think we make a lot of bad assumptions and just ignore things that we assume are costs the people are doing that could be incorporated like this.
Thank you, Darwin. Thank you, Tara.